We know that metals transfer electrons to nonmetals, creating a positive cation and a negative anion, which then their attraction forms an ionic compound. So one of the things we have to be able to do is write the formula for these ionic compounds. Now, ionic compounds don't form individual units called molecules. Instead, they form what's called a crystal lattice, which is where all of the ions are kind of packed together. So when we write formulas for ionic compounds, what we're actually writing a formula for is the ratio of the ions inside this crystal lattice. So what we use is something called the principle of electrical neutrality. Now basically all that means is that when you add the charges together, overall the total charge, the sum of them, has to equal 0. So it's quite straightforward when the charges have the same value. So for example, Na is a positive charge and chloride ion is a negative charge. So when we look at this, we see, so you have a +1 and a -1. So to cancel, you would just need one of each. And so when we write the formula, we get NaCl. And this is called, we would call this, name this sodium chloride. Now, it's also, you could think of the same, another time when it would be 1-to-1. Let's say you have a calcium and an oxygen. And the calcium is in group 2A, and it's a 2+, and an oxide is in group 6A, oxygen's in group 6A, so the oxide is a 2-. So again, looking at the charges, you have a 2, a positive here, and a 2 negative there. So the numbers that have the same value. So it's going to cancel out if we just have one of each. So it would just have one calcium and one oxide ion. And so that would be CaO. And that was, so we call that calcium oxide. And we can even go further, even if they both have 3. So let's say we have aluminum and nitride ion. So again, looking at their charges, so aluminum is in group 3A, it has a 3+. Nitrogen's in group 5A, and it has a 3-. So see how they both have 3? So in order to add them up, a 3+ and a 3-, it would just take one of each of those ions to cancel. And so when we wrote the formula, we would just have one of each. And this is aluminum nitride. So what I want you to take away from this is when you have the same number in the charge, so a 1 and a 1 in the first example, or a 2 and a 2 in the second example, or a 3 and a 3 in the third example, in those instances the ratio of the ions is always 1-to-1. So you just write each letter and that forms your ionic compound. So over here, this group right here, this is what, when they ask for the formula, this is the formula right here. Okay, so what if it's not 1-to-1? Because not everything's... If it's not 1-to-1, then we can think about it. Again, what we're thinking about is that when we add the charges together, we need the sum to equal 0. So let's say, for example, I have barium, which is in group 2A, so it would be a 2, and then I have a chloride in group 7A, so it's a 1-. So looking at these charges, this is a 2+, and this is a 1-. So those two charges are not going to cancel if I just take one of each. In fact, thinking about it, in order to cancel, I would actually need 2 chlorides, right? Because then if you think about it, you have on this side a 2+, and now I would have a negative here and a negative here. That would be 2-. So to get these two to equal 0 when you add their charges together, you need 1 barium, but you need 2 chloride ions. And so to tell how many you need, you write it as a subscript next to the element. Okay, so superscripts like this are used to write charge. Okay, subscripts like this are used in formulas to tell how many you have. So this case we need 1 barium and 2 chlorides. And this would be named, you just name it, the barium is just, positive ions are the same as the element, and then the negative ion you change the ending to IDE, so it's barium chloride. Now there is a shortcut called the crossover rule, and I want to show you this now. And we'll do a couple examples with this. So here are the 2 ions, and let me just write underneath what we would get. So a crossover rule says if you look at the charge on the opposite element, you can figure out how many you need. So like to figure out how many barium I would need down here, I would look up at the charge on chloride ion. And chloride ion is a 1, right? So then I would only need 1 barium. Of course, we don't write ones. I could think of 1 there, but I wouldn't write it. And then for the chloride ion, so I think, okay, how many chloride ions do I need? You look up at the charge on the barium. Now we're not making the chloride positive and the barium negative. This is just a shortcut to help us figure out how many we would need to get the sum of the charges to 0. So chloride ion, I look up here, there's a 2, and so then I would say a 2 down there. So then my formula ends up being, like we had up there, BaCl2. Okay, so let's try another example. Oops, sorry. Okay, so let's try, let's say we had potassium and then phosphide. So if you want to think about it mathematically, if you're looking at it, potassium is a +1 and phosphide is a -3. So if I added those two together, it wouldn't cancel. So in order to get this to cancel, I would actually need 3 potassium. Now let's think about this in terms of the crossover, because I think this is kind of handy. So to figure out what I need for my subscript for potassium, I would look up here and I'd say, okay, phosphorus is a -3 ion, so that means I'm going to need 3 potassium to balance that. Then to figure out the phosphide down here, so now I want to look at my phosphide. To figure out how many phosphide I need, I'd look back here, and that's a 1, so I would need 1 phosphide. So I get K3P, and this is called potassium phosphide. Well, let's try another one. So what if I have aluminum, bromide? So it's a 3 and a 1, so they're not going to match right away. So to figure out aluminum, I see that bromide is a 1, so I'm going to need 1 aluminum. That would be, and then bromine, I look back, aluminum's a 3, so it's going to take 3 bromide ions. So I get aluminum bromide. Whoops. Now what if I had something like aluminum with oxide? Okay, so on this one, you see you have a 3 and a 2. Well, the first number 3 and 2 have in common are 6. So I'd have to have enough so that both have a charge of a 6. But the crossover helps me out a lot this way, so I think, how many aluminum do I need? Well, I look up at the oxygen and it has a 2 charge, so I'm going to need 2 aluminums. How many oxygen am I going to need? I look at the 3 up here, and I need 3 oxygens. You see, if I had aluminum, if I had 2 of them, this right there equals 6 plus. And oxide ions, if I had 3 of them, this equals a 6 minus. And that is what we're trying to do. So when we add those together, they cancel. This is just named aluminum oxide. Now, one thing that's important to remember, to get the formula you need to know the ions, or if you know the name, you need to know the ions. The only way to get the formula of ionic compounds is you need to know the ions. And I think I'm going to write that down right here. Need to know the charges to determine the formula of an ionic compound. So if you're being asked to figure out the formula of an ionic compound, be sure you know the charges.